morning, one and all. Myself, Dr. Amit Kumar. I am MSc, MPhil, and PhD in physics, and presently working as a assistant professor in physics in Markanda National College, Savhat, Markanda, Kurukshetra. Today, I am here to present a micro teaching skill, addressing the teaching skill to set introduction for a topic, and the topic that I selected for today lecture, or you can say the presentation, is interaction of radiation with matter. Now, so start my presentation with a caution that the most of time when the person accompanying the patient or go to a X-ray diagnostic lab, then he and she are restricted to stay outside the X-ray diagnostics lab by the inspector of that particular lab. Or alternately, you can say you may find this type of symbol, or say a signboard outside the lab. So my question is why? So let me answer of this question, because inside the lab there exists a large amount or large dose of radiation, X-ray radiation, which cause a negative impact on our body. Then my next question is whether the radiation is present only at the inside of this lab. Okay, wait. Answer of this question is as we already have discussed. Okay, so is the radiation is present only inside this X-ray lab? So answer of this question is no. We have natural radiation everywhere. Everywhere we can find radiation, maybe due to natural or due to artificial. So here we are not talking about the artificial radioactivity. Here we are talking about the natural radioactivity or natural radiation present in the environment. So the cosmic rays is continuously showering in our earth due to outer atmosphere, and the soil and the rock present underneath the, you can say, soil or underneath the ground contain a large number of radioactive material like uranium, thorium, potassium, and so on. And these radioactive component or nuclide is transferred from soil to plant, and then this plant to our food chain through different possibility of herbivore, carnivore, omnivore, like that. And radon is also coming out from the soil, which is inhaled by our body, and continuous radon are deposit, or say alpha dose are deposit on our lung. Also, if we talking about our body, then our body itself is a source of radioactivity, or it contains radioactive potassium in our bone, which continuously emit the gamma ray. So that's why we can say the radiation is present everywhere. Now my next question is, what is the effect of these natural radiation, or say you can say radiation, in our body? Okay, so this diagram well represent the radiation effect on our body. Radiation dose are measured in millisievert per year. Per year is understood, so millisievert, and the exposure is cumulative. Exposure is cumulative means today we absorb say 0.1 millisievert of dose, and in the next day if we receive 0.1 millisievert dose, then this dose is continuously accumulated in our body. Okay, so depending upon the effect of radiation on our body, or symptom, we can divide the type of radiation mainly into the three categories. The first one is the tolerance level. The tolerance level means this level is started from 0.1 millisievert and goes up to 20 millisievert. Depending upon the dose, the effect on the body are different, and up to 20 millisievert per year we cannot detect any type of symptom on our body that can evident that the risk of cancer due to these radiation are there. In the second category, when the dose are vary from 100 millisievert to 1000 millisievert, again no intermediate symptom are there, but as the exposure is increased with time, or you can say the long term effect may be there, depending upon again the dose, there are different possibility. and at the level of 1000 millisievert, there is a 5% chance of the cancer. Now, in the third category, where the risk is very high, the dose level are starting from 200 millisievert and goes up to 10,000 millisievert, and these are potentially fatal. Means you can see the risk, you can see the effect of radiation as soon as the radiation is incident on our body, or immediately at the dose of 100 millisievert you may find within few days the जो absorber होता है, or you can say the patient will die. Okay, so on the right hand side, the body, human body is or you can say a model is given where the point eyes, thyroid, lungs, stomach, reproductive organs, skin, bone marrow, etc. These are the point where the radiation are more susceptible, or you can say vulnerable. And the other point is also susceptible, but the dose are slightly common. You can say the tissue weighing factor for these part of the human body are very large. Okay, so my next question is, how we can detect the radiation. The radiation can be detected with the help of radiation detection devices, which is called radiation detector. And these radiation detectors detect the radiation present in the environment. You can say in environment means in soil or in air, in water, etc. Or on the surface of people means if some radioactive material are present on the outer surface of our body, that is called external contamination. That is also detected by radiation detector. The third one is if somebody ingest or inhale the radioactive material through the food chain or through air pipe line, then this can also be detected with the help of these radiation detector. And if somewhere the radioactive material is there and radiation is continuously coming out and fall on a human body, and this is called exposure, which is also detected by these radiation detection devices. Now, so my next question is how these radiation detection devices work. So this is the time, okay, or you have to understand the basic principle of working of radiation detection devices. So before starting the radiation or the working of the radiation detection devices, first of all we have to know what type of radiation are present in our environment. So these are few examples, not all. The alpha, beta, gamma radiation and the neutron radiation, you can say also neutron radiation is present in the outer atmosphere. So these radiation interact with the material and in a different way depending upon the energy. So that's why this is important to understand the interaction of radiation with matter, and we will continue the same with the coming lecture. And from today's lecture, I think you become well aware with the fact that how it is important to understand the interaction of radiation with matter. Thank you. Thanks for your kind attention, and we will discuss these things in the next lecture. Thank you.